And you can do a lot of it very simply because Wireshark is so wonderful. You almost need nothing but Wireshark to analyze data once you've got it. Anyway, let's get rid of this and make this thing big. All right, so there's a whole book, The Tao of Network Security Monitoring, and this has now become more popular. It's something small businesses and medium businesses still don't do it, but they're all being pushed into it. I remember I was very impressed when one of the students in my hacking class told me they tried to do their hacking homework at work, which I do not recommend. And so he's at work and he downloaded something like Kane and started doing his homework. Immediately his phone rings and they say, "What are you doing down there? Knock it off." So they're doing network monitoring. They have something that logs it, and if somebody downloads a hacking tool, it pops up and says, "This guy is downloading a hacking tool, go shoot him," and so they, and that's efficient network monitoring. I don't think, he was working at a bank, and I would never have told anybody to do hacking homework at a bank. Don't do it at the airport either. I don't think they do much network monitoring, but they have no sense of humor. There's even signs up telling you, "We have no sense of humor, don't make a joke." So yeah.
So when they monitor, do they check signature or do they check where it's coming from?
Both. And typically what you have is actually an IDS, that if anything bad comes on a list that's automatically updated by the manufacturer, a thing alert pops up, this guy's doing a bad thing, that guy's doing a bad thing. And then you can go find them and make them knock it off, or you can just block their network access or pop up messages on their screen or do various things you might want to do about it. So the network monitoring is definitely a very powerful tool, and it's more practical than it used to be, which is true of all these security things. I remember malware analysis is something I used to think was impossible, but with modern tools, it's more approachable. So same things here. So this is what you might want to do on the network, of course. You'll find out the scope of the compromise, how many machines are infected, how many machines are phoning home, and you can make a timeline of when things occurred. And another important thing we'll come back to is that if you have a hacker that hacks like a Windows machine, they very commonly erase the logs afterwards to hide their tracks, but they can't erase the network logs because it's on another device. And although in principle they could hack into the network device, in practice that is very rarely done. Most people practice with hacking tools to hack into Windows and Linux, but hacking into a router is something most people don't know how to do. So there's 4 basic types of network monitoring. The most common is an IDS that just pops up alerts for things that are known to be bad. This is what Snort and Suricata and these other products do. It's just like antivirus on a network. It has a list of bad things, and when a bad thing happens, it pops up an alert. And then it may block it at a firewall. Most likely it just alerts you. But that's the simplest kind of monitoring. And you don't really get a lot of information about what happened. You don't get all the packets. You just get it like an antivirus log. You get, "I detected this threat," and alerted you. This is popular, of course, because you don't have to be very skilled to operate. It's just like antivirus. You install it, you turn on the updates, and then hopefully you don't worry about it until an alert goes off, and then the alert message will give you a clue what to do about it. So that's the natural thing to get. If you don't really have a security team, and you're trying to get your poor overworked network administrator to please run security, they like to buy these all-in-one package solutions that try to do everything for you, so it isn't a lot of extra work for them. The next thing is you might want to record the traffic itself. You could record just the headers, typically the first 64 bytes of each packet, which will get you IP addresses and MAC addresses and the protocol, but not all the data included. Or you could record the entire packets and store them. The problem is storing entire packets gets to be a lot of data, and it's very often encrypted. So you can't get a lot of good out of that higher level information anyway, unless you bother to decrypt it, which is yet another hassle. So that's why just the headers are often what you'd like. And that's often, in the law enforcement community, they often have these orders to just get the call trace logs, where I just want to know who called who and what time. I don't need to hear the content of the call, I just want to know who sent what to whom. That's often enough to prove your case. Anyway, so that's an issue. And then there's another kind of network monitoring, common at ISPs, which is NetFlow. This is statistics, where you do not store the full packets, and you don't respond only to known evil things like an IDS. You record statistics like how many, you have a flow, like this person connects to a server and then they download something. I'll record one event. This person downloaded so many bytes from this server at this time. You just keep track of what, and this is what you might do if you're, for example, charging people for bandwidth or trying to notice how many people are downloading things and things like that. That's high-level statistics. And NetFlow is the Cisco product that does this, and it's trying to set the standard for it. So you can control what kind of use is being made of your network, even when you're not even particularly looking for abuse. You just want to know what regular use is happening. So here's the most common type, where you have Snort or Suricata or some other device, and it has a bunch of rules. And if a rule matches the traffic, it alerts you, this appears to be a scan, this appears to be an unauthorized SSH shell or whatever it is. It's got indicators, signatures in there, and if you have simple indicators, then it doesn't slow down the box very much. So if you have just an IP address and a port, like certain IP addresses you don't want people going to, like game sites or Tor exit nodes or something, or IP addresses in a country that you don't like, you could just flag anything that comes to those addresses, and that would be pretty easy. There are complex indicators that look for strings in the layer 7 data or reconstructing the session across many packets, and if you do those, that's a heavy burden on the sensor. If you have a network sensor recording packets and you burden it too much, it will start dropping packets. One of the students did a Wireshark project in a lab and sent in, I happened to notice that Wireshark had captured 400,000 packets and dropped 17% of them. So it can lose a lot. Anyway,
Quick question,
yeah.
Where's the bottleneck? Is that on the network speed, or is it on the CPU, or what?
It can be either or both. It's complicated to tune them up so they really keep up with a fast network. So here's a Snort rule. Snort is the standard in the business. Snort was the first open source IDS. Everybody uses it, and a whole lot of other people use Snort rules. There's just a format for these things, and I have some links here that will show you how to write them. But the point is, you've got, this one's commented out, but it's a TCP rule that takes from anywhere on the external network to anything on a home network on port 22. So this will detect all SSH connections. And then it sends a message, tells it what message to print out, and then the rest is showing what category of rule this fits into and how many attempts. This says if people make more than 5 attempts to connect to SSH in 60 seconds, we consider that an attack and log it. So alert fast is something you can put in your Snort configuration file, and then it will have a special file that it puts in alerts. So you can look at that file or cause that file to be emailed or sent by an instant message to the administrator or anything you like. Here's a rule that detects fake SSL certificates. And this is worth mentioning in your book because it's a Mandiant product. Now, Mandiant became famous by analyzing the Chinese hacks on American companies and figuring out everything about who was doing it, who was on the team, where they were in China, what their position was in the Chinese military, just everything. And they called them APT1 to about APT13. And this is what the APT1 people used. They used a fake AOL certificate. And they detected which certificate it was, and now they can detect when these, and so if anybody's using that certificate, that's gotta be that particular APT group. And Mandia is the company that I think more than anyone else actually showed that it was valuable to your business for them to know about the attackers. And that was the response to something that had been going on for about 8 years and kept mostly secret in the industry, is that everybody knew China was hacking everybody. And nobody wanted to admit it publicly until Google spilled the beans in 2010. And after that, it was possible to publicly talk about it, at least some of it. I imagine that the public Mandiant APT report has quite a bit that was removed and kept secret at respect to the US government, but I don't really know. Anyway, so this group called Emerging Threats writes Snort rules, and there's a large Snort user community posting up rules and putting them in groups, and you can subscribe to them and download them, and on it goes. This one here is a content string. It looks for this 7C A2, 74 stuff. This stuff up here is the serial number, the certificate. And then it looks for this mail at AOL.com later, which is the issuer, the name of the, not the issuer, but the domain name it covers. So those strings would be very unlikely to match anything except that certificate. And I would think that rule would be a fairly expensive rule to run because it has to do layer 7 matching of the strings. Anyway, then you can do header or full packet logging. If you're just doing, there's 2 reasons to do this. One is because you're an incident response team and you're trying to find bad things to create indicators of compromise, to scan the network with your live response system. And the other thing is you're trying to collect evidence for something else, like they are researching somebody, they suspect somebody's an insider and they're trying to get evidence on them, or something like that. You might also want to log all the traffic going to a high-value server so that you can answer questions when people say who is accessing that data. And you want to say, I captured everything, I kept logs of everything, I can prove that nobody accessed that data except the properly authorized people. Anyway, so if you're going to use your packet captures in law, then you have to consider having a proper chain of custody. And that means you're going to have to store them in some way with a signature so they can't be altered. You're going to have all the equipment physically secured in a locked room so nobody could walk up and tamper with it. And you're going to have it properly secured over the network with like long passwords or certificates so nobody can reasonably connect over the network, and it should be monitored to detect any such entrances. If you're going to take this data to court, you're going to have to justify that it was handled and collected in a forensically sound manner. Well, with proper chain of custody. Anyways, that's thoroughness. The IDS system, in principle, your IDS has an option to record the entire packet capture, but in practice, if you turn that on, it's going to slow down so much that it's not going to be able to detect the real threats. In practice, your IDS can either be alerting you to real-time threats, or it can be recording all the traffic, but the same box cannot typically do both of those things at the same time. So tcpdump is the command line tool that people use all the time. It's very easy. If you do tcpdump -X, it captures the entire packets. So it will start with this header information at the top that just shows you the time and date, and then a source and destination, port number or device name, followed by, this is IP address followed by port number, but it does by default resolve it to names if it can. And then it has the flags, the acknowledgement number and such, and then it just has the hexadecimal bytes, byte by byte, just like Wireshark does at the bottom, so everything in the packet is there. And if you want to limit it to 64, you can use command line switches to do that, and then you'll just get the first 64 bytes of each packet, which will include the IP addresses, but not the data. And that's often what you want, so you don't have such a huge amount of data to troll through. And NetFlow, like I say, NetFlow is statistical monitoring. You have a NetFlow-enabled device, or you put NetFlow sensors on your network, and it records general information about it. For every flow, every session where someone connects to a server on a port and transfers data, until that session ends, it all boils down to just one number: source, destination, IP address, and port, the protocol, and then how many bytes were sent, and how many packets were sent, and what time this happened. Just that kind of data, not anything about the contents inside there. And you can buy commercial visualization processes. These Fluke, I think it's a Fluke device, they'll sell you this thing. It's a little laptop you carry around, plug in your network, and monitor the NetFlow data. These things are common. And then you can see I use this at a large data center to track down why the traffic is not flowing properly in some area, and so on. All right, there's open source products like FlowTool and Argus. These are ways to take a PCAP file and make a graph out of it. It's just going to do the same thing that expensive laptop does, but for free. So you run it through, you use Argus first to convert your PCAP file into an Argus file, and then you use line commands using rgraph to graph the contents of the Argus file. So what he did here was take a PCAP file and then plot out a minute and a half of data to see who's been connecting, and sort it by port. So the blue line is HTTPS and the black line is HTTP. And the answer is nothing much is happening except one big download here. Some large connection was made at this one time and not much of anything else. This kind of linear graph is usually for the birds. If you get in any kind of field where there's a wide variation in the response, it's better to use a logarithmic graph, because then you can see everything. And the fact is, even though this was an awful lot of packets really fast, this was a pretty big download too that just happened slower. And you wouldn't see it if you didn't switch to a logarithmic scale. But anyway, this is just a way to find areas of interest in a packet. As you see, much more primitive and simple, less pretty, and that's why it's free. So I got a few iClicker questions. Come grab one if you need one. Make this thing big. All right. All right. Yes, yes. Okay. All right, so what kind of monitoring gives you the ability to reconstruct the files that were transferred over the network? All right, looks like I can quit at 30. I'll wait till 35. I saw a few coming in. All right, I guess 30 would have been. All right. So that you got to have full packets for that. Nothing else will do. That's the only thing that has all the layer 7 data. All right. What kind of monitoring does NetFlow perform? And it should have a capital F there. Quit at 30. All right, and that's the high-level statistics. Not a very popular answer, but that's the way it is. All right. What does Snort do? Quitting at 30. All right, it just does event-based logging, and when it matches rules, it sends out alerts saying, I recognize this and that event I configured to recognize. What does tcpdump do? Quit at 30. All right, tcpdump does two of them. It does full packets and it does headers, depending on how you configure it. It can do either one of those things. All right, well, I think it's probably logical to take a 10-minute break at this point. Let's pick up at 5 minutes to 7. And we can finish this up. Let me save what I've got, which is chapter 9.